In question 4 we have a diagram showing a crane with two identical steel cables, each of length 35 meters. In A we're told the cable has a mass of 4.8 kilograms per meter. Where to find the weight of a 35 meter cable? Well, weight is mass times gravitational field strength. We have 35 meters at 4.8 kilograms per meter times the gravitational field strength, giving a weight of 1600 newtons. In B, the cables will break if the crane attempted to lift a load of 1.5 times 10 to the 6 newtons or more. Where to find the breaking stress of one cable? We're given the cross-sectional area of each cable at 6.2 times 10 to the minus 4 square meters. Well, stress is force over area, and so the maximum force over 2 times the area of the cable, as we have two cables, gives a stress of 1.2 times 10 to the 9 pascals. In C, when the crane supports a load, each cable experiences a stress of 400 megapascals, with each cable obeying Hooke's law. We can ignore the weight of the cables and we're given the Young modulus of steel at 2.1 times 10 to the 11 pascals. In part 1 we're to find the weight of the load. Well, force is stress times area, and putting in the values we get a force of 248,000 newtons. This is for each cable, and so the total weight, as we have two cables, is 2 times this at 496,000 newtons. In part 2 we're given the unstretched length of each cable at 35 meters, where to find the extension when supporting the load. Well, the Young modulus is equal to stress over strain, and we're given stress, so I've just left this as stress. The strain is change in length over original length, and rearranging we get the Young modulus as stress times length over the change in length. Rearranging again for the change in length, the extension we're asked to find, we can then put in the values, and this gives 6.7 times 10 to the minus 2 meters. In part 3 we're to find the combined stiffness constant K for the two cables. Well, K is force over change in length, so we have the total force over the change in length, and this is 7.4 times 10 to the 6 newtons per meter. In part 4 we're to find the total energy stored in both stretched cables. Well, energy is half times the force times the change in length, so we can put in the values, and we have 1.7 times 10 to the 4 joules.